In this lesson, we're going to solve quadratic equations that have two or more variables. To do so, we're going to again go back to the square root property where if you have x squared is equal to a number and you want to solve for x, you can take the square root of both sides, provided that you put this plus or minus in front of it. Let's use this in example 1. The formula for the volume of a cone is given by V for the volume is equal to 1/3 pi r squared h. And what we're going to do is solve this equation for r. I'm going to draw a picture of this cone and then label what r and h represent. So here's a picture of a cone. H represents the height from the top all the way down to where it first hits this circular portion on the bottom. So this distance is h. And then r represents on the circle the radius. How far you go from that center point out to where the circle is. These are the two dimensions that you would need to figure out the volume of any cone that looks like this. But I want to solve the equation for r, so let's start there. V is equal to 1/3 pi r squared h. Since I've just solved for r, I want to get this piece by itself, meaning I got to get rid of 1/3, pi, and h. So I'll start with the 1/3. To get rid of 1/3, I'm going to multiply both sides by 3. So multiply the left by 3. I'm going to do the same thing on the right. I'm going to choose to write it as a fraction because those 3's cancel. This changes my equation to 3 times v is equal to, 3 times a third is just 1, and I have pi r squared h. All right, I want r squared first so I can then solve for r, but to do so, I'm going to divide both sides of this expression by pi, but also at the same time by h. I have to do that to both sides. My equation is now 3v divided by pi over h is equal to r squared. At this point, I can now go up to this property and say, oh, well, if I want to get r instead of r squared, I'm going to take the square root of both sides, provided that I put this plus or minus on the left. So I'm doing this. I get the square root of 3v over pi h is equal to r as long as I put that there are two solutions. Now for this particular problem, technically r represents a distance. So all this work is valid, but there's no way that I'll have this negative answer since r should always be either 0 or some positive number. So technically for the context of this problem, r is equal to the positive square root of 3v over pi h. So this would be the answer to this question. For example 2, we want to solve this equation for y. There's no context to this problem. It's simply just relating three variables, x, y, and z. And the goal is to get y by itself, meaning I first have to solve for y squared. I got to get rid of this x. I also have to remove this 2. My first step is going to be to multiply both sides of this equation by 2. I'll copy down my equation, and I'm going to leave some space for multiplying the right side by 2, but also multiplying the left side by 2. Just like in the last example, those 2's are canceled down to 1's, and the left side of this equation is now just x plus y squared is equal to 2 times z, which I'll just put 2z. Okay, so I need y squared by itself first, and I see that there's this x here, so I'm going to subtract x from both sides. I now have y squared is equal to 2z minus x. And the second my equation looks like this, where the y squared portion is alone, I know I can apply the square root to the entire side on the right and also on the left. So I have to make sure that this square root is applied to both of these terms. This entire thing is under the square root. On the left, I have y. On the right, I have the square root of 2z minus x, but I have to put this plus or minus in here. There's no context to this equation when we solve for y. So the plus and minus could both make sense. That means the answer to this problem is both solutions.